Hi class, this video is going to help with our simplex method. And this is section 6.2. We're going to skip 6.1. It was like kind of a method that was leading you to the simplex, but I taught it for 2 semesters and all it did is confuse people. So we're just going to skip to the real method. So the way that I'm going to show you is through an example because there's no other way to do it. And we're going to be using, it's a matrix method, and there isn't a matrix calculator for this method. It is by hand. So please, you're going to have to learn this because it's on the final exam as well. So this is 6.2, the simplex method. And the first simplex method that we're going to learn, let me get my paper in the right spot here, is going to be a maximum in the form less than. That's important because we have a different method for every type of problem. So a minimize is a different method. And then if we mix up our constraints, greater than, less than kind of thing, then we again have another method. So excuse me, this isn't our traditional less than. So graphically it'd be like I have some kind of bounded region, and in there somewhere, probably on the edges, on the corner points, is our maximum or our solution. So if we talk about our maximum, so this is the first question here that I'm going to walk through. So we're going to maximize, and we're going to have P equals, profit equals 50 times X1 plus 80 times X2, same as the X and Y, they like X1, X2. And we call this our objective function. Okay, so that is called the objective function. If I say then it's subject to, maybe x1 plus 2x2 is less than or equal to 32, and it's subject to 3x1 plus 4x2 is less than or equal to 84. These are called the problem constraints. I almost forgot the S in there. Constraints. Constraints. The S is hiding in there. And we usually also have non-negative constraints. And goodness, you get to where you just kind of ignore these, but really they have to be bigger than 0. Okay, and they're the non-negative constraints. All right, so then what we're going to first introduce to this is something called a slack variable. Okay, so what we're going to do is we're going to, maybe I'll define them, slack variable. So the way that we're going to do this is, what if I want to change this to equals? So we're saying everything is less than 32. But does that mean you get all the way to 32? No, you could have, you could be a little bit off on that. So it's not an equal, it's a less than. So what I'm going to do is I'm going to write this with what we call a slack variable. So I'm going to say x1 plus 2x2 plus a slack variable makes this equal to 32. So I am adding in a slack variable, and those we're going to call S1 or S2 or S3. Typically, a problem is just going to have 2 slack variables. Sometimes they'll have 3, but usually 1 or 2, and that's it, because otherwise the problems get too long. So then we need a different slack variable for the second equation for the less than to pick up that slack between the less than and what you have, okay? Or it could work with greater than too when we get to that problem. So to write the second one as a slack variable, we'd say 3x1 plus 4x2 plus S2 equals 84. So now we have rewritten this with our slack variables. That's our constraints. Now we need to rewrite the rewrite the objective function. Oof, can't think. Rewrite the objective function. And if you are not currently writing this down, rewind, write this down, because these are the steps you're going to need, and it'll be great to have like something written out for yourself. So the objective function, we are going to rewrite to equal 0. So this is our objective function. So right now it is P equals 50x1 plus 80x2. And we're going to rewrite this to be on the side with the P over here. So we're going to minus them over, but I want the P to be last. So bear with me. I'm going to rewrite this to negative 50x1 minus 80x2 plus P equals 0. Okay, and that is a slack equation of the maximizer, the objective function. Okay, so what do you do for the objective function? You move everything over with your P, with your profit. Okay, so we have this one and these two, and now we're going to write what we call the initial system. Okay, so the initial system is going to be our slack variables, and I'm going to leave some spaces. You'll see why. It's going to go x1 plus 2x2 plus s1 equals 32. Okay, second slack variable or equations, 3s1 plus 4x2 plus s2. We don't have s1 in the second one. I want a gap for being 0 there. I want a gap here because there's 0 s2s there. Now, last, always on the bottom, will be our objective function. So then I'm going to have negative 50 x1s minus 80 x2s plus p. Oh, I forgot the equals on this one. This one equaled what, 84, and this one equals 0. There's your initial system. So see how the three slack variables are kind of on their own over there? I don't know. I guess you call the lat p a slack variable. Oh, it's the answer. It's what NP ends up being, the max profit. All right, so this will probably, you have some questions just being able to write this initial system. Now we're going to go to our initial Simplex Tableau. I can't get the paper to move. Okay, so my initial Tableau is going to look like this. So this is your Simplex Tableau. Okay, and you're going to have your S1. Oops, I only need 3. S2, and your P. And you're going to have X1, X2, S1, S2, P. Okay, so this is going to form a matrix, and it's just going to be taking those numbers. So 1, 2, 1, none of these, 32. That's your first line. Now you see why there's spaces, because they become 0 in our Tableau. Second line will go 3, 4, 0, 1, 0, 84. Bottom row goes negative 50, negative 80, 0, 0, 1, 0. So we write it with the gaps so that when we write our Tableau, those gaps fit in perfectly with our zeros. Okay, so now we've written our initial system. So the whole goal now will be to get rid of these negatives in the bottom row. Okay. Now, I was trying to follow my notes here. Basic variables. So we want to define a couple things here. We have something called a basic variable. Now, a basic variable is something in your Tableau that only has one non-zero. Has exactly one non-zero element. Okay. All right, so which ones are basic variables right now as we start? S1, S2, and P. Those are our basic variables right now. Our non-basic variables so the non-basic variables, I had this little note on here and I couldn't figure out what it was. Non-basic variables contain more than one non-zero element. So at the start, which ones? So let's put the basic ones in here. So at the start, it's S1, S2, and P. And what would be these ones would be X1 and X2. All right, so our non-basic ones right now are X1, X2. Also, when we have something that's non-basic, it equals 0. We say it's just equals 0. It doesn't actually give us a solution. Right now, our slack variable equals 32. We have not used any of that 32. So our slack is equal to 32, slack is equal to 84, and our profit is equal to 0 right now. That's what these ones represent. X1 and X2 are both 0 at the beginning. What we want to do is find those X1 and X2 that maximize our profit. Okay, slack is just in there. Maybe you don't use all of X1 to get the maximum or something like that. Okay, so our basic variables are non-basic as we start. If we say from starting point, and we ask for the basic or the solution is this. So from right now, we would say x1 equals 0, x2 equals 0, and we would say s1 equals 32, s2 equals 84, and p equals 0. So right now, can't even see it. Right now, if you were asked from this starting point what those values mean, that's what they mean. That's what we're starting with. Okay, so let's solve this to where we can find that something, a better profit than 0. I've made nothing, I have no profit. And according to my constraints, I've used none of my 32 or my 84. Not helpful. So we're going to do what we call our pivot variable. So when we do a pivot, it's going to be one full process, one pivot. What that will do is it will switch one of these and one of these, basically. You're going to have one going in, one going out. And the pivot column is the most negative. So when we look up here on the bottom row, which one is the most negative? Negative 80. That chooses your pivot column. So let's start with that. So the pivot column is the most negative in the objective equation or bottom row. And it's not solved until you have no negative in the bottom row. Most negative in bottom, objective, equation row. So this is also called your entering variable. All right, so that's our x2. It's entering. It's going to be coming in with a value, and out is going one of our Slack variables. Okay, and your pivot row. How do we find that pivot row? And the way that we use the pivot row is we look at the ratio. So what do I mean by that? The ratio. So we know we're in this column. We look at 84 divided by 4 and 32 divided by 2. And that is going to give us our ratio to find our smallest and our pivot row. So let's write that out. First, you use the pivot column. So we just did that. We just only looked at the pivot column. So you're going to use the pivot column and find the smallest ratio. Smallest ratio. I don't know if I guess the way that I guess I'll just write it out the way I have. Use the pivot column and find the smallest ratio by dividing each element in the last column by the corresponding element in the pivot column, by the positive. I'm going to add that in there. Positive, non-zero. Okay, element in pivot column. Some of you will need that written out. Some of you just fast forwarded to my next part. And the variable to the left is the exiting variable. Yeah, we'll see that in a second. All right, so let's go up and look at what I mean by that. You could have paused that and rewind that if you didn't get it all the way written down. I mean, we're looking at this column right here, and we need to look at the ratios. And the ratios will be 84 divided by 4 and 32 divided by 2. This gives me 16. This one gives me 21. And which one is the smallest ratio? This one, right? So this means this is my pivot row. This is my pivot column. So this is my pivot variable. I know I just drew that out because I mean, it's really going to go way quicker than this. So first pivot, we find the most negative. We take this number and divide this number by this number by this to find the smallest ratio. And then we find our first pivot. Okay, one thing to note, it cannot be 0 and it cannot be negative. If like that 4 was 0, we would have just picked 2. Like you just ignore that row. It cannot be negative or 0. That would be the positive non-zero in our written out part. Okay, so now what are we going to do? So we have our entering, oh, and what would be our exiting variable? Ooh, so what is entering? Entering in is x2. What will be exiting is S1. S1 will no longer have all 32 slack. It will now be used, and x2 will have a value. That's the idea of entering and exiting. Okay, so our pivot element, you might want to label that. This is our pivot element. Okay, pivot element. All right, so here are a couple rules that I just want to pause and say as we do these steps. You're never going to interchange any two rows. Never. We could do this. It's a legal move in matrices. It's not in Simplex. Step one, you're going to transform the pivot row so that the element is 1. So right now our pivot is 2. We got to divide everything in that row by 2 because it needs to be a 1. Has to be a 1. Then our next step would be to add multiples of the pivot row to the other rows to form zeros in all other elements. So take a minute, pause, write this down. Okay. What are we doing? We're going to make this a 1, and that a 0, and that a 0. Then it will be a value. Okay. So let's start by taking row 1 and dividing it by 2, or you could have times it by 1/2. That's the same thing. And 1, 2, 3. I can't see my original, but the first number was 1, so now it's going to be 1/2. The second number was 2, so now it's a 1. The third number is a 1, so now it's going to be a 1/2. And then we had a 0, that stays 0, the 0 stays 0. 32 divided by 2 is going to give me 16. Okay, so we'll do our little line here. Another thing is we commonly do a dotted line to separate that objective function once we start doing our pivots. And this row would have stayed the same. That's a 3, a 4, a 0, a 1, a 0, an 84, a -50, a -80, a 0, a 0, a 1, a 0. So what did I change? The pivot, which I still want to be circled, is now a 1. First step. Now we're going to do is get a 0 here and a 0 here. And the way that we're going to do that is we're going to times that top row by -4 and add those rows together and replace it on row 2. And then we're going to times that top row by 80 to add row 1 and row 3 together to replace on row 3. So let me write out what we're doing. We're going to take -4 times row 1, add it to row 2, and replace it on row 2. At the same time, we're going to do positive 80 times row 1 plus row 3 and replace that on row 3. Okay, let's do that. So the top row is not changing. I'm going to have 1/2, 1, 1/2, 0, 0, 16. Notice I get a little lazy and I don't write the x1, x2, s1, s2, p above them all. You sure can. It's a lot of steps. So I get a little bit lazy and I don't write them. You might want to on your first couple so you remember which ones are which. All right. So if I take -4 times 1/2, it's -2. -2 plus 3 is going to give me a 1. Okay, -4 times 1 plus 4 is 0. -4 times 1/2 is -2. -2 plus 0 is -2. -4 times 0 is 0 plus 1 is 1. -4 times 0 is 0 plus 0 is 0. -4 times 16. Don't make fun of me. What is -4 times 16? You probably already said it. -64 plus 84 is going to give me 20. Okay, last row. I do the 80s. 80 times 1/2 is 40. 40 plus 3 Oh, 40 plus negative 50. I was like, no, I did something wrong. Duh. 80 times 1/2 is 40. 40 plus negative 50 is negative 10. Okay, and then 80 times 1 is 80 plus negative 80 is a 0. 80 times 1/2 is 40 plus 0 is 40. 80 times 0 plus 0 is 0. 80 times 0 plus 1 is 1. And 80 times 16, I don't know, 16 times 80 equals 1,280 plus, right, because it was times this, plus 1. No, plus 0. Sorry, wrong row. It's 1280. All right, why I got a little messed up on there, I don't know. That's what happens. Okay, so now we did our very first pivot. That is what a pivot is called. You find the pivot variable, you make it a 1, and you do 2 row operations to change the 2 rows that aren't the 1. Now look, right now, 1, this x, so if we did this, x1, x2, s1, s2, s, not s3p. And this was S1, S2P. So if we're looking at this right now, X2 now has an actual value, 16. Okay, right now our profit is 1,280. So now I'm making 16 of one of the items and I have a profit. Now I'm not all the way done. How do I know I'm not done? I still have a negative in my bottom row. So now we have to do that same pivot again and get rid of the negative in the bottom row. Okay, so let's go ahead and do that. Somehow I lost the rest of my notes. Okay, just flipped that over. Nope. Problem 3. Not that I can't do it without, don't really care, but. Okay. So what are we going to do next? We're going to say this row right here is the most negative. So this is our pivot column. All right, so then we have to look, these are both positive, non-zeros, so we can use either one. So then over here, we're going to take 20 divided by 1, which is 1. Okay, and then we're going to take 16 divided by 1/2, which is 32. Okay, so which one's the smallest? That's going to be this one here. So this is the smallest. And that makes this one here our next pivot. Okay, is that pivot already 1? Yes, I don't have to divide. It just let me skip a step. So now it's already 1, so we're going to go on and we're going to make that a 0 and that a 0. So I am going to take a negative 1/2 times row 2 to add to this one. So we're going to add that to row 1 and replace it on row 1. And that's how we are going to get our 0 where the 1/2 is. And the 0 down here would be 10 times row 2. Always going to times by that middle row. And then we're going to add that to row 3 and replace it on row 3. All right, let's go ahead and do that. All right, 1, 2, 3. So our middle row is staying the same. 1, 0, negative 2, 1, 0, 20. Nothing changes on that row. So then look, negative 1/2 times row 2 is, so negative 1/2 times 1 is negative 1/2, plus the 1/2 is going to give me 0. Negative 1/2 times 0 is 0, plus 1 is 1. Negative 1/2 times negative 2 is a positive 1. 1 plus 1/2. 1.5 or 3/2. You could write it as a decimal. It doesn't matter. Okay, then negative 1/2, where was I, times 1 is negative 1/2, plus 0 is negative 1/2. Negative 1/2 times 0 plus 0 is 0. Negative 1/2 times 20. Negative 1/2 times 20 is negative 10. Negative 10 plus 16 is 6. All right, bottom row, 10 times row 2. 10 times 1 is 10, plus this one is 0. 10 times 0 plus 0 is 0. 10 times negative 20, excuse me, negative 2 is negative 20, plus the 40 is 20. 10 times 1 is 10, plus 0 is 10. 10 times 0 is 0, plus 1 is 1. 10 times 20 is 200. 200 plus 1,280 is 1,480. All right, and if I did this all out right, I'm here. I am officially done. How do I know? The bottom row doesn't have any more negative indicators, so we're done. Now look, our x1 has a value, our x2 has a value, our slack variables do not have a value, but our profit does. So the way that I would write this answer out is I would say that my x1 equals 20. My x2 equals 6. And my P equals 1,480. My S1 equals 0 because there's numbers all in the row, right? That makes it a basic variable, so it's just 0. And there you go. There's our 5 variables and their values. So whatever we're selling 20 of the first one, 6 of the second, and we're going to maximize our profit at 1,480. Oof. That is how you solve these. Okay, so I have another video that I made when COVID went crazy. And so there's going to be one other video that has me walking through this one and one from the next section. And then there's also going to be videos from the company as well. Really just get in there and try these. I know you're going to have questions, but there's your